All right, we're going to start. Thanks for coming. So we're going to talk a little about and showcasing scale, Gen AI, building production-ready LLM application. I'm pretty sure you already heard a lot of AI topic today and probably tomorrow and other many YouTube channels. So, but we really more focus on open source project and tools, how to make it better experience with your AI app that. So before we jump into the session, we got one question. How many people actually develop AI application right now? Doesn't matter Java, Python, JavaScript. Okay, that's cool. And in production? Oh, very nice. Who has some experience with Java, by the way? Ooh. Okay, so my name is Daniel O from Boston. I am Java champion and ambassador, and among others, CNCF contribution a lot, many years. I'm Deborah at Red Hat / IBM. Here's my friend, Kevin.
Yeah, I'm Kevin, based in Switzerland, and yeah, we're pretty much twins, right? I mean,
we all Java champion.
Yeah, he says Red Hat, I say IBM, but yeah, somehow we're in the same team.
Yeah, that's true.
Yeah.
And by the way, we are reading one of the TAG, CNCF, Technical Advisory Group, Specifically Developer Experience. So if you are interested in contributing back to CNCF with the developer experience, doesn't matter any program language and platform. And yeah, we are already looking for the great people, smart people, and please reach out to us after this session. So yeah, let me really talk about some kind of journey for generative AI with the LLM. So you probably know the LLM and AI, artificial intelligence, actually was born almost 100 years ago, not just a couple years ago. At a time, and then AI is just more conceptual thing, not technology at a time. And then the technology kept evolving until we met agentic AI today. And during the machine learning, deep learning, and predictive AI, just analyze a lot of stuff from the billions different data and find some unusual thing like fraud detection kind of stuff. And a couple years ago, like 2.5 years ago, OpenAI, they unleashed up in the world new like a ChatGPT based on generative AI, which is generate actual new content, video, image, text, and even source code as well. And agentic AI like evolving from generative AI to do something autonomously decided by LLM rather than you can give some instruction manually and explicitly. So this is but don't be confused. Generative AI is an actual application, just like your business application, like a Java, Python, JavaScript, or whatever you use. And other side, their AI model could be large, could be small, depends on your purpose. It could be like an instruction model, chat model, or image generation model, or some kind of interpretation model. So between AI model and AI application, you need just some kind of library or tool or platform, whatever you call, to communicate and then give us some AI capability. That's what we're going to talk about today. But for that, we need to more focus on developer rather than AI engineer.
Yeah.
Sorry for that.
Yeah, I mean, the real question is like, how can we get more traditional application developer onboarded into this journey of adopting AI into our applications and add some value to AI, right? Because creating models is one thing, but how do we actually integrate those into our system? So how do we kind of do that? So we tried to break it down a little bit. Oh, this clicker's going crazy, Daniel.
That's not mine.
What the?
Okay, I'm going to be your job.
Please, yeah, what the?
Okay. By the way, this is like a Kevin's leg, skinny chicken leg.
This was me. Yeah.
Not me. I have a muscle.
This was me the other day when I was trying to figure out how to work with AI, how to figure out which model to pick and all that good stuff. But I'm going to try one more time with this clicker and see what happens. See, it goes. I click on it and it just like goes 10 slides at a time.
Okay.
You have a bad clicker, Daniel. All right, so we actually have a background in application development, and both with mostly Java, and so like this is again kind of me, right, trying to figure out how to work with AI. But before we do that, because we didn't go back enough slides, but this is the slide that I really wanted. So to get started, really, is finding an LLM to use, right? So you might be using an LLM from some provider, OpenAI or Gemini or whatever.
Copy-paste.
Yeah, or an open source LLM that you run on your machine or using VLLM or whatever. And then you try some prompting, see how it behaves, and maybe add some of your data to see how everything is going. And then comes the real meat of the job. How do we actually integrate that LLM into our application? And that means there's a lot to do. We need to find the right stack, the right framework to do that. So whether you're using Java or Python or whatever, you need to find a stack that allows you to do that, figure out which libraries to use, and then how do we actually prompt a model from our code, and then how do we receive that data? How do we create kind of structured data from that? What about keeping state between the different calls? Because the models themselves are, of course, stateless. And then how do we create agents that can have specific capabilities and make them work together? So it's a lot that we need to think of. And then finally, how do we operationalize it? How do we actually get this to production in terms of how do we serve the models, which is not necessarily the application developer that's hopefully in charge of that, but we need to figure out what endpoints are available, monitor what's going on, the deployment of our agentic apps that we've created, and then incorporate them into platforms. So this is, again, me as a Java developer. And you can see we created, we're working with AI. And if you look at the keyboard, you'll see that maybe I'm more confused about why the keyboard is on the wrong side of my screen there more than anything.
This is the best example. I generate this image with AI, of a stupid
Clearly.
AI. Yeah, you see that? Where's my keyboard? In the back side, there are many screens, but I cannot finger on my keyboard. Use the right tools, right?
Yeah,
LLM.
exactly. So we're going to try to do better than generating this image with actual software, right? So again, we're Java developers, and so there's a framework that does that pretty well in the Java space. So we use the Quarkus stack and then use LangChain4j to do that integration. So those two projects work really well together. And then we can use more agentic things, and we can add more tools with Model Context Protocol, and there's some more new features in LangChain4j as well. So we can actually create enterprise software, integrate AI, and then leverage all that stuff that we've been doing in the Java world already. So the way that you do this is basically, if you're familiar with Java and Maven, this is how you add a dependency to your application, right? So you can see that we add this Quarkus LangChain4j OpenAI dependency in this case. That can also be a Quarkus LangChain4j Gemini or whatever other provider you're using. We just used OpenAI here because it doesn't necessarily mean that you're using ChatGPT, but the OpenAI specification, right? So there's many kind of model providers that use the OpenAI spec, so you can use that same spec to integrate models into your application. So by just adding this dependency, actually I can already start calling a model from my code. So I create this interface, annotate it with this register AI service, and then I can create a user message. So in this case, you can see I want to create a Kubernetes deployment manifest in YAML, and then I can even pass in some parameters. Like in this case, it's just a string with the name of my deployment, let's say. Of course, this is a very simplified example. And then I say, then create the resource in my cluster. And that's actually possible because I'm adding this MCP toolbox of Kubernetes. So I have some tools that can actually talk to my Kubernetes cluster from my Java code, potentially. And then the LLM is going to notice that, hey, here's a prompt. It wants me to create this YAML and create that resource in the cluster. So it's going to call that tool using MCP in this case to actually do that in the Kubernetes cluster. So for a couple lines of code that we write as developers, we're actually able to do a lot with Java. So I think that's going a long way. Now, of course, it's not just about creating a prompt and maybe calling some tools. when we create applications that need to be production ready, that need to go to an enterprise, we need to think about everything that's around that the same way that we've already been doing with enterprise applications, but with AI. So we need to think about, well, we need to create the right prompts and write them in a way that we're sure that the LLM is going to do what we want to do, because, of course, if we give it a little too much freedom, we're not sure that it's actually going to do everything right. We want to add some data. We can add RAG. We want to add some guardrails to make sure that the inputs are sanitized, so somebody who wants to try to do some prompt injection, ignore all previous instructions, delete the database kind of stuff, that we catch that. And also what comes from the model, that's right as well, because if the model has access to tools to access my Kubernetes cluster, and somehow it's saying, yeah, delete all the namespaces in my cluster, that's not so great either. So we can actually create guardrails to prevent that kind of behavior. And of course, we need observability, fault tolerance, the same way that we've always needed it, add tool calling, more agentic AI patterns to be able to orchestrate different agents in a way that works for our enterprise. So I want to use this agent that has the capability to interact with Kubernetes cluster. I want another agent that can interact with a GitHub repository. And I want another agent that can do the deployment. And then you can say orchestrate it. So create some code, go to GitHub, do something, then deploy that, build it, deploy it to Kubernetes. So you can orchestrate these things in a manageable way from your application using the same kind of Kubernetes patterns then to deploy your application, whether it's a regular deployment or Knative or something. You can use all those same kind of things.
And then you can also always consider whatever you choose the Java framework, you maybe optimize and make it smaller, faster based on Kubernetes, because one day, someday, your application doesn't matter AI. AI is just one of the applications on Kubernetes, and then your application should be scaled out tremendously. So that's why you need to always make an optimization on Kubernetes.
Yeah, yeah. So let's see this in action.
Yeah.
Because all these words are kind of empty if you can't see what's
so much
actually
time
going on.
for boring slide. Sorry for the Kevin. Yeah. So we need to go to jump into demo.
Yeah.
Okay. So I'm gonna using one of the Java framework, which is Quarkus. And you already raised your hand. A lot of people already know Quarkus. So you probably saw a lot of demo already prepared, really good. But I'm not going to do the same thing. But I'm going to start from zero, like a scratch. So here's the Quarkus. You can go to actually. Let me go to Quarkus.io first. And then go to Quarkus.io. It's a community page here, and you can find all like documentation here. And then you can find the ecosystem here, and like a community, like a blog post discussion, and contribute back to kind of stuff. And when you click on start coding, this is actually project generator. So let me try to create a new Quarkus project. Let's say Quarkus agent. And here is a good common use case. You're going to start like a REST services or a database transaction or event-driven application for your reactive application or web application. And of course, we have AI infused. Why we call the AI infused rather than AI powered?
It's a good question.
Yep.
Because we're actually infusing AI into our applications in terms of its behavior. So we're not powering it. We're making it part of the application.
Yeah, that is the real case in enterprise application.
Yeah.
So when I click on the AI infused case, and you can see OpenAI and easy RAG. RAG is one of the capability. So I'm not going to use RAG. However, I'm going to use MCP today. Using that and then just generate my code.
And if you're confused as a Python developer, LangChain, what is the difference between LangChain and LangChain4j? So LangChain4j was inspired by LangChain, by the Python LangChain project, and then they kind of diverged, but the name stuck for Java. So it can do a lot of things that LangChain can do, and it can do some extra stuff and vice versa. So, that's kind of the story behind that, why it's called the way that it's called.
That's a really good point. So first of all, I just generate my Quarkus project. And when I go to source, there's nothing exists, just empty project. And I can start Quarkus dev, the development mode, which is the starting point to start your runtime local machine. And then Quarkus Dev Mode actually provides a fantastic visualization, which is the Quarkus Dev UI. But in order to access the Dev UI, you have to put in some kind of rendering runtime, which is a Vertex. So I can actually edit lively, try to like a Vertex extension, and then in the meantime, my Quarkus runtime automatically recompile, restart automatically without any human being intervention, which is just so cool. We call that live coding. And then I can actually change my Java version because Java 26 are already out, but I'm going to using Java 25, more like a stable one. And when I change it 25, it automatically restart my runtime. It's really good for me. I just need to only focus on my development stuff rather than like a non-functional capability. So let's revisit Dev UI here. And then here's a LangChain for Z, some core, and then I don't see any AI service like a 0 because this is an empty project. So let me try to create a new simple agent here, which is like an agent, and I'm going to create just plain Java interface. And then let me try to make this plain Java interface as generative AI with just one annotation. REST AI services came from LangChain for J, and then this one annotate make my plain Java interface as generative AI. Of course, I need to add some like a prompt engineering stuff implementation, which is like a one method, like a, let's say, agent. And then here's the user method annotation, which is pass down my all user prompt into my LLM, which is a kind of, let's say, question. And then I also need to set like a system message, which is another prompt engineering method, which is only initial message when my AI, generative AI application start is sending to my LLM. Doesn't matter Llama or like a Quen and any model you pick it up. But this is define and specify your model's behavior and scope. For example, if I say, oh, you are a professional guy, just like a Kevin Dubois, and it's super smart. But if you say, oh, you are like a 3 years boy, always hungry and mini, and nothing interesting at all. And then whatever you pick it up, great model, it always answer like a 3 years boy. So that's the initial message. Not gonna sending the message every time you finger on keyboard. This is the one time whenever your application start. So
is that the prompt? Is that the system message you're going to give it? You're a 3-year-old boy?
No, absolutely not. And it ruined my demo today. So I'm going to do that you are like a professional, not amateur.
Yeah.
Professional.
And these system messages are really important to set that context for the LLM because even if you tell it you're a developer versus you are a senior developer, ironically, it will actually create better code in your code assistant if you tell it you're a senior developer, which is really funny to me.
Yeah, totally. And then I'm going to add one more plain text here. Typo. Okay, so just my instruction, all available tools should be utilized without explicit request. So this is make my generative AI application, just change it to agentic AI application. But I don't need to actually implement which tool needed to access first or second or third from my LLM. I just need to set this instruction, make my generative AI application as agentic one. Of course, I need to use like OpenAI pretty simple to access AI model, the small model like a GPT-4 mini. And I'm going to set some MCP server more publicly, but you can also use your own custom MCP server based on Java, Quarkus, or JavaScript, whatever you want. And then here's two things for Quarkus. Quarkus already integrate MCP with the two ways. One is a streamable HTTP connection, and like using URL, or Quarkus automatically start up MCP server using the npm package manager with some this command line. So here's a few stuff. Let me try go back to Dev UI first, and then I'm going to reload. And now you will see one AI agent, which is an agent. And then here's the chat UI, which is so good for me. I don't need to implement some fancy web UI using JavaScript. I can still verify my AI capability with this provide out-of-the-box feature.
Yeah.
And,
so this dev UI is when you run your application, your Quarkus application in Quarkus dev mode. This is kind of comes out of the box. This isn't available on production, so people don't go in and access all your stuff. But for a developer, this is really great because they have all this view over what's going on in their application.
So, and then also Quarkus keep integrating ecosystem like a Kafka or some Grafana or Swagger UI. And whenever you add on that library into Quarkus project, you don't need to go another browser and open that web UI. So Quarkus Dev UI actually integrate that in one single printable point.
Yeah. And this is actually exposed as an MCP server too. So all this runtime knowledge is running as an MCP server. So if you want to integrate that into your code assistant, it also has access to all the knowledge about what's actually running on your system in terms of the application. So it's kind of really cool because it can see your code and it can also see your runtime and everything that's going on there. But
that's correct. And this is my activity monitor on macOS. And when I try to find npm process, I don't see anything, so just nothing. So when I start my chatbot stuff, and then it automatically Quarkus start MCP server on my local machine, a separate process, and then my AI application going through that MCP server and then connect to external MCP, could be Google, could be chatbot, any kind of stuff. Here's my prompt. So my name is Daniel, he's my friend, and then we are looking forward to great restaurant, like some barbecue place in Atlanta, and then around the Georgia World Class Center. And then we need to get direction. We're not going to go into like a 20 drivers away. We probably find a walkable distance. We can also want to go to some restaurant over 4.5 rating from Google. We're not going to go to 3.5 rating. Yeah, going to be take a big risk. Okay, and then sending to messaging to my Slack channel, lunchtime for team. And then I have lunchtime. I don't need anything. Okay, and then I'm fired up. And then go back to my IDE, and then here is logs. In the meantime, you can see that it's so many logs. It's an already tool kind of thing. You can see parameter and so many logs. So this is autonomously LLM decide which tool you're going to access that. And then go back to activity monitor. Now you can see that NPMs are automatic startup for like a Google Maps because I need to get direction. And then also Brave Search is open source Brave, like a Google search kind of thing. And the memory, because my LLM keep remember and memorize what conversation between tools and LLM and end user. And then in the end, they're going to sending the recommendation to my team channel based Slack. So that's why you can see automatically.
Yeah. And the logs are really important here too, because if you're running this on production, you want to know how many tool calls were made, where were they made, how long did they take. So all those, the logs, the metrics, and the traces are all available as well with this application. So you can ingest those into your systems and make sure that everything.
That's why you got some observability.
Yeah.
And then so here's the thing. Yeah, and here's the thing. So generative AI, you can actually define the business logic, and you know how many times the LLM accessible, and then how many tools you're going to access, like obviously. But autonomously accessed by LLM to tools, you don't know how many times LLM actually access. Maybe 1,000 times, maybe 10 times, until the LLM find the best solution for you as your personal assistant. And then now you can have some direction and like a rating of 4.9. That's good. Okay. Yeah, and then here's the address of 564 Continental Olympia Park, driveway, and kind of thing.
Who knows Zach's Steakhouse here? Anybody can recommend it? No?
Local? Okay. Nobody.
Well, we're just going to have to trust
Google. Oh, okay. Right. And then I'm going to my lunchtime channel, and then you can see exactly the same thing here. So just like I ask like a human being, and it actually decided, oh, perfect. Yeah. So, but back to the my end of the demo, ID tool. Oh, what's happening? Ooh. Something.
You need to like drag it down somehow.
I don't know. Oh, okay. Something happening. Oh my God. Okay. So what I wanted to talk about last thing is go to my agent. You can see that except for import line, we have like a less than 10 line to make a Gen AI and change it to like a agentic AI. Of course, you can add more complex thing and like Kevin's tool like MCP toolbox, and then you can add it to A, and among others, because you probably have a multi-agents, not a single one. Okay, that's one. I'm gonna hand it over to Kevin, and then wrap it up. Oof.
Yeah, so I mean, now we know how to create this application and has all these cool AI capabilities. Of course, when we go to production, how do we actually integrate this into the bigger system, right? Because of course now we need some AI servers probably running on our system.
Demo was just my local. Now time to move it to the production.
Yeah. So that landscape, you've maybe seen something similar to this. So if you know the cloud native landscape, this is somebody's take about the AI landscape, and they did this in, I think, in March 2024. So we can only imagine it's even crazier, right? So the typical guy, right? Like, and Daniel here thought it was funny to.
Today so Kevin Dubois, and he got a freaked out. Okay, which like, project I'm gonna
too
use
many
it?
projects.
Yeah, too many projects.
So fortunately, thanks to CNCF and thanks to Cloud Native, we can kind of break it down into projects that we're mostly familiar with, right? So you've heard of different projects here during the keynote as well in terms of Kubeflow and Kserve and all those different projects. So you will definitely need those if you want to productize your LLMs in your environment and not rely fully on somebody else's cloud LLM. But there's a lot of projects out there that you will probably need to integrate because it's not just an application. You need some sort of data pipelines. You need different projects. So you can see we can kind of go up the stack with all these different projects. And of course, we don't have time to go through all of this, but this kind of gives you an idea of what you need for a platform. So there's a project that's called Open Data Hub that's trying to be like an opinionated take on how to combine these kinds of open source projects into a platform that you can use to build AI. And this is actually the basis of OpenShift AI as well. So this is actually being used in production by the Red Hat customers in the form of OpenShift AI, but this is the upstream project behind it that the Red Hat developers are working on. So for you, this is a nice kind of opinionated take on how to create a platform where AI engineers can go create their, train their models and deploy their models, and then we as application developers can tie that into our development workflows and then build something that's really cool. So if we kind of go back to how do we break that down, so step one is kind of learning and experimenting. Using Quarkus is, I think, a really good take. Of course, we're very biased. But I think Daniel showed how you get a really nice, quick feedback loop, even if it's Java, right? The people think is really slow and cumbersome. We showed that just with a couple lines, you have a really nice kind of user interface, and you can work with it with LangChain for J. You can use MCP and all those different things. And then you can serve your models with something like VLLM onto Kubernetes with LLMD and all that crazy stuff that they're working on. For me as an application developer, that's maybe less relevant, but it is important to know that we have a platform that we can rely on in our systems using cloud native tools that we can maybe use Open Data Hub as kind of the thing to bring it all together. So
basically, you can identify your application functionality capability on your local machine with the local LLM, and then you can go to like a VLLM, more production-ready inference service and runtime with your actual application and a more big model. And then now time to use scale up, like at scale in the cloud, that is Open Data Hub.
Yep.
Like some journey, how to get, how to evolve kind of thing. That's it.
Yeah, that's it.
Pretty much time on it, and
well
feedback, please.
Yes. Yeah, so if you can leave us feedback, that would be great. Thank you very much.
Yeah, we're going to stick around less for today and tomorrow. And if you have any questions, feel free to reach out to us, like a social media or in person. We are more than happy to chat and ask about this topic or any kind of open source related to CNCF. And happy to chat. And thanks for joining today. And last word, Kevin.
Yeah, we just touched a tiny little bit of what's possible, of course, because there's so much more we can do, but there's only so much we can do in this session. But if you want any kind of see any other cool stuff, we can show it, and we can talk about it all day long. So
Thank you so much.